Okay. Well, let's take that. So,
All right, guys, let's take a look here. My intent with this was not to freak you out or make you feel bad or whatever. Right, it's not my intent. I wanted to let you guys have a chance, just fresh, just totally cold, to see what you could dredge back up. For some of us, maybe it's been a while, or we just barely passed our last time, whatever. So it's kind of like, is it really, really deep down, or is it really not there? So I wanted to let you guys pull up what you could, so that when I explain it, it's a little bit, it's got something to attach to. That's my intent with this. Can you remind me, how do I simplify something like this? 2 over the square root of 3. Yeah, which means rationalize the denominator. So what's that mean? Multiply by rad 3 in this case, because it's a square root, it needs 2 things inside, it's got 1 3, so I give it one more mutant 3 here. So I got 2 rad 3 over 3. Whoop-de-doo. Now what's different on this guy? What sucks about this guy? It's got a stupid -1 attached. So what you do is it's related to difference of squares. It's called the, anybody know? I don't care if you know the name really. It's called the conjugate of it. So you multiply what I call its difference of squares pair. It's a little buddy dude. Square root of x -1, so we're going to multiply top and bottom by square root of x plus 1. What that does is it kills the middle term. And that's the only place a radical could be left alive. So I love with the radical stuff, I often sound like I'm explaining how to be a tyrant, right? You kill the radical element that's in your country. But so if I multiply top and bottom by square root of x plus 1, no idea why I made this so huge. On the bottom you get, what's rad x times rad x? X. And then minus rad x plus rad x. The middle terms cancel, as promised. And -1 times 1 is amazingly -1. Do you guys notice why you do not want to FOIL the top? Because you already got an x -1 there. It's going to die in a second, right? So these die. So you get square root of x plus 1. You guys with me? Now notice something right now. Well, one of the very first things we're going to do is related to what I'm about to say. Try to plug a 1 into the original problem. What do you get? You can't. Well, worse than that. What do you really get? What do you get on top? 0. What do you get on the bottom? 0. This is one of the coolest, or maybe freakiest, or maybe whatever. It's like the immovable object and the unstoppable force. You ever heard of that? What happens when they collide? Spin. But if I've got the top 0, then the answer is 0. If I have the bottom 0, the answer is infinite or undefined, whatever, right? But so it's 0 and infinite at the same time somehow. 0 divided by 0 ain't 1. It's something called indeterminate, which is, of course, a little worse than undefined. Undefined means you're done. Indeterminate means you ain't done yet. Try to plug a 1 into the answer. What we got? What do you get? 2. All of a sudden you could do it. Now, what's the only number that, well, besides the radical can't be negative, but the only number that's in the domain of this that you cannot use in the original is 1. So it's undefined at 1. But by doing this, I'm allowed to see what it wants to be at 1. I can see where the circle goes. The circle goes at 2. Okay, maybe some of you guys are with me. I went way beyond the actual problem just to give you a little taste of something called limits that we'll be doing in chapter 2. Okay. All right, pass it. This is very basic, but sometimes if it's been a while, I don't know, what do logs mean? Exponents. A log is a power. That's why all the properties of logarithms are the same as the properties of powers. So the answer to this is going to be the power that 8 needs to become 2. Now, something to realize. If this was log base 8 of 1, what would the answer be? This was log base 8 of 1. What do you raise 8 to get 1? 0. What's log base 8 of 8? 1. So log base 8 of 2 must be between 0 and 1. Does that make logical sense? Yes. What's log base 8 of 1/8? What power do you put on 8 to make it become 1/8? -1. Right? So if the inside is less than the base, is less than 1, the answer is going to be negative because it's got to flip somehow. But if the inside is bigger than 1 but less than the base, the answer is going to be some kind of a fraction. It's going to be a root. What root do you take of 8 to make it 2? Cube root. So 1/3 power. The answer is 1/3. No, yes, maybe, no. What do you do to 2 to make it become 8? What power? You use 1/3 power. So how do you make it go backwards? 1/3 power. To make 8 become 2 again. So the answer to this is 1/3. The answer to any logarithm is a power. The power that the base needs to become the inside thing. That's all logs are. It's just bullshit. When you first learn it, though, that's the first time you ever see a little word here. And then, of course, you learn about sin and cosine and all that kind of stuff, and then you're like, all right, I'm used to words now. But this is the first time you really see a word as a function symbol, right? So that's a lot to get over, but the basic idea of logs are easy as shit if you let it be. It's just the power you need to make the base become that. That's it. C makes me cry. And if you made a mistake on this, today it's fine. I'll let it go. I'm not even going to grade these, really. I'm just going to look at them. So, okay, I'm not talking directly to anybody. Several people put this down. But this is so desperately wrong. So desperately wrong. If you believe that's the answer, then you think the square root of 13 is 5. Anybody believe the square root of 13 is 5? That's silly, right? But isn't 13 9 plus 4? And if you distribute the square root like you thought you could here, then you should be able to do it always, and then you get freaking 5 for the square root of 13. That can't be true. Now, come on. Can you distribute powers across sums? So what's a plus b squared? Is that just, this is an old mistake that you'll never make anymore, right? This is the mistake people would make. Why can't you do that? Because what are powers based on? What operation are powers based on? Multiplication. So they will play well with multiplication. They are not based on addition. They will not play well with addition. So what if I had this instead? That's crap. What if I had ab squared? What's that? A squared, b squared, all day long, because since exponents are based on multiplication, they will play well with it. It will be easy to work with it. Stupid addition inside, I got to write it twice and FOIL that stupid thing, right? So what is the square root? It's a power. What power is it? 1/2 power. So it can only do what powers can do, which means it can't distribute across addition. That's bullshit. So what can you do instead with this thing? Maybe you can do something more like this. What can come out of there? What can come out of this? Yeah, what can come out? 4. And what's the square root of 4? 2. What's the square root of x squared plus 16? I don't freaking know. Done. Do you guys see that? That's going to happen often enough. And if you do this all the time, the problems become really easy. So it doesn't take long to get to the wrong answer. So that's crap. So don't be overly optimistic with this stuff. You can't do that first step. But it made it so easy, Jeff. Yeah, I know. You were done with it quick. Quick to grade, too. How are we doing on these first 3? Are we all right? Semi all right? Again, the chapter 1 homework, I did say that. It's up there on the website. So the chapter 1 homework in chapter 1 itself is a review including a lot of these ideas. So the worse you did on this little worksheet, the more you want to go in for help somewhere, me or the tutors, with chapter 1 to get that down. Because any of this stuff can pop up whenever it wants to in this class. Okay. What about this dude? Obviously, what do you need? Or I don't know, it depends on which way you did this. I need to know what the LCD is, so I can kill all the freaking bottoms, right? So we cool with that? So
Of course, I'm going to take the one I can break up and break it up so I see what it's made of. So you factor this little dude here. So what's this guy need? He needs an X, so I give him an X. What's this middle guy need? He needs freaking everything, poor little dude. So give top and bottom that. I make all the bottoms the same, so then I can kill them since it's an equation. The fact that it's an equation lets me do stuff like killing things. So I make this. Then I can multiply both sides by this so they all just go away. Does that feel familiar? That's the way I teach it anyway. I like that idea because you have to get used to getting LCDs anyway. So if you get everything to have the same denominator, you can just kill them because it's an equation. Students learn this and they think they can kill every fraction that lives anywhere. But of course it's the fact that it's an equation that lets us do this. And then what's left alive is 15. Might as well distribute the negative 2x. Big mistake there's a negative there and not change the sign on the second dude. Oh shit. Is everybody with me so far? Then I want my x squared term to be positive, so I'm going to add stuff to this side. So I'm going to get 2x squared minus 8x makes it minus 7x, and then minus 15. Is that cool? I just added a 2x squared, subtracted 8x, subtracted 15. Get it all equal to 0, of course, so I can factor. And then this is factorable. So watch this. 2 times 15 is 30. Negative 30. 10 and 3 would make negative 7 if the 10 was negative. So how do I make 10? Put a 5 there. And then I put a 3 there. Sweet. You do that whatever way you learned. Everybody kind of with me still? 3x minus 10x. Yay. So then what's the answer? X is... What do you hear? Yeah, subtract 3, divide by 2. And this one, of course, will be 5. And what do you have to check, of course? What do you have to check? What kind of problem was it to begin with? A problem with shit on the bottom. So what can't I let happen? I can't let the bottom be 0. Any of these x values make the bottom 0? No. So both answers are valid. It's not really a check, but at least, does it make it undefined? No. Is this all coming back a little bit? Alright, I love you guys. I don't know if I can play poker with anyone. Don't show him anything. How do you do this one? This is like that tyrant thing. If you have a radical element in the country, you isolate the radical element and then you kill it. If I square right now, that so desperately sucks because I'd have to FOIL this side. Again, you can't square each piece. It's not distributive across addition or subtraction. So what do you have to do first? Add 2. I like it. So then you get root 3x plus 1 equals x minus 1. And then, of course, you square. This is where people sort of forget about foiling for some reason. And then you get it equal to 0 again. And this is, of course, where people make all kinds of weird shit here, but it's only 2 terms. And what do you always try first when you factor? You always try GCF first. They'll save your ass. Just take an x out. And so you get x is 5 or 0. And of course, what do you have to do now? The original equation had places where certain x values won't work. So you have to check your answers to make sure it's still okay. I want you to notice something. Watch this. Do you remember this step here before I squared it? Right? Right there? You guys with me? That step before I squared it. A square root, can it equal negative? Can a square root equal a negative number? All right, tell me how.
If it's a square root of 4, it's either 2 times 2
So there are two roots of 4, negative 2 and 2. But what is the square root of 4? No. Okay, you're getting me worried. So everybody knows there's 2 roots to every positive number and negative if you want to bring complex stuff in, right? 4 has 2 roots. 2, because 2 squared is 4, and negative 2, because negative 2 squared is 4. When I write square root of 4, that is called the principal square root. That is the positive root. That is what we decided that symbol means. So the square root of 4 is 2, period. End of story. If I ask you, what is the square root of x squared? Why are there multiple answers to that? Because you don't know what the shit x is. So if you just say square root of x squared is x, why is that wrong? Can somebody give me an example that shows that's wrong? What if x was, of course, what can a square root not be? A square root can't come out negative by definition, right? We have decided that the square root symbol is the positive root. So just tell me an x value that is not positive. What if x is negative 1? Then this is saying the square root of 1 equals negative 1. What did we just say? That doesn't make any sense. By definition, you guys with me? So the square root symbol is defined to always be positive because it is the positive root. So what if you want the negative root? Put a negative sign on it. Then you get the negative root. So what is the answer to this then? This is where the answer is. Oh, you were there earlier. What happened? This is where the answer is. Yes, because the answer's got to be positive. Let's check it. What's the square root of negative 1 squared? The square root of 1, which is 1, which is the absolute value of negative 1. Holy shit, right? So that's when I have to put absolute values, when I don't know what the number is. But when I say square root of 4, freaking number's 4. So the answer's 2. There's no uncertainty. I don't have to cover my ass for it possibly being negative because I know it's freaking 2.
So you can only use the absolute value if it's a variable.
If it's an unknown. Yeah. Because the answer can't be negative. Okay, maybe. I love you guys. I love you. Okay. So, my point here was, right here, before I took a square root, when I plug a 0 in there, doesn't it say square root of 1 equals negative 1? So 0 is not an answer, right? Or if you plug it in the beginning, just plug a 0 in, you get square root of 1 minus 2 equals 0 minus 3. Is 1 minus 2 equal to 0 minus 3? Is negative 1 equal to negative 3? No. So you got to throw 0 out. Why did freaking math, stupid math, come here, I wish you guys slapped. Why did math give me freaking wrong answer? I did every step right. Stupid math. Because we didn't do a good job here. When I squared here, I lost information about if this was negative or not. So math goes, all right, from here down, the answers are these. But you did weird shit here, you better go back and check. I don't know if you guys get that. Have you ever wondered why sometimes you have to throw an answer out? Doesn't that make you a little angry? Did the whole problem right, but I got to throw that one out. It's not math's fault. It's the process we used to solve did something weird. If this was negative before, now it's positive. So I lost information about what it was. Plug a 0 in, it was negative 1, but then I squared it, now it's 1 when I plug a 0 in. All right, that's enough of that. You get that or you don't. So hopefully your teacher said something about that, and just like, throw one of them out, next topic. I mean, you gotta know why. 5 is gonna work, let's see. 50 plus 1, 16, 4 minus 2 is 5 minus 3, 2 equals 2, check. So that's an answer. Yes, sir.
Do we just want to go back and check those whenever there's like a square root in the original?
Anytime the equation parts have restricted domains. Or in this case, it's even a different thing than that. There's a radical that's got a restricted domain, but it's a restricted range even. Anytime you have something funky in your equation, like denominators or radicals, you've got to check your answer to see if there's what's called extraneous roots, extra answers. Okay.
Let me give myself a clean sheet. There we go. So number 3. This one looks so horrible, maybe. Oh my God, if anybody multiplied this shit out. I feel bad and sad. The instructions say factor. You almost never multiply when the instructions say factor. So what am I going to try to do? What method am I going to use? You're like, we don't know you, man. I don't know what you're going to do. But what'd you do? Did anybody do anything? So what if I write this? 6m squared b cubed minus 21m b to the 4th. What kind of problem is that? Yes, GCF. Kick ass. Do you see how these are the same problem? What's m? What's b in the problem I gave you? This is m minus 5. m minus 5 is a single number, isn't it? So m minus 5 is a single thing. So how many m minus 5 is going to take out? 3. Okay. How many m is going to take out? 1. Okay. And then I can look at the numbers. So what number can I take out, of course? 3. I can take out 1m and 3m minus 5s. Bam. It's just GCF. That's all it is. 6 divided by 3 is 2. I had 2 m's. I took 1. I got 1 left. I had 3 of these. I took 3 of these. I got none of them left. Poor little me. 21 divided by 3 is 7. Took the 1m I had. I had 4 of these, so I still have 1 of these left. So then I can clean the inside up a little bit. So 2m minus 7m is negative 5m, and distribute the negative, I get plus 5. Let me stop for a second. You guys with me? That's just a GCF problem. Yes? Here? So a 3 can come out, right? How many m's can come out? 1. And then how many m minus 5s? 3. And then I write what's left here. What's left here?
The 6 divided by 3 is 2.
That's right here. That's right here.
And why do you have 3m?
All right. Let me do this here. So let me write this a little bit. So I do often when I first teach this try to move it over a bit. So here's what I'm taking out. And here's what is left. Yeah, cool. That's not a bad idea. When I teach this, I tell them to move it over a bit so they can see what's coming from where. Is that cool? So here's what I took out. Here's what's left in the first dude. Here's what's left in the second dude. There's no cube there, Jeff. And now I've got 2m minus 7m is negative 5m. Negative times negative is plus 5. And what's the last thing I could do? Take out a negative 5. That is bread and butter problem. That is sink your teeth into it, just work it and get it. That should not be a problem. Should not be an issue. This is no concept really, nothing. Just straight up nuts and bolts, just work it. Just do it. And then there would be other steps later. So we will see a lot of problems like this. That will happen. And then we'll do other stuff. Normally what we'll do is we'll set this equal to 0 so we can see all the places where this is 0. That's going to mean something with calculus later. The first step is just, are you able to factor? And here's everybody's most hated form of factoring. I don't blame you too much because it's the one form that you can't really sink your teeth into. You've got to memorize the form. When I teach this, I relate it to the movie Pulp Fiction. Anybody ever seen Pulp Fiction? Anybody ever seen? Yes. You remember the scene, of course, where the guy gets his head blown off in the back seat and somehow you're laughing about it. Do you remember that scene? The movie really makes you think about yourself. But they had to call somebody. They had to call the wolf, right? The cleaner. And you're all like, dude, what the shit? This is calculus. So the way I relate it to this is there's a little dude and a big dude when you do cubes. I'm not going to teach you the whole thing, so hopefully you've got something to hang this on. Can you break everything into 3 parts? Yes, so it's a cube. It's 2 terms. It's everything. So this is 2b, 2b, 2b. Is that cool? That's ab cubed. And what's 27w cubed? 3w, 3w, 3w. So in the little dude, he's just a little dude. So one of each goes into the little dude with the same sign. I put one of each of the little dude. So of course in the big dude, I'm going to put two of each. So overall, when I foil, I'm going to get 3 like I'm supposed to. It's sort of like when I do squares. Don't I put 1 here, so when I multiply I get 2? It's the same idea. So right here, what's going to go there? 2b times 2b, 4b squared. What's going to go at the end? 3w times 3w, 9w squared. It's the middle term that's the freaky-ass term, right? Because look, what do I have so far? I got my 8b cubed, right? I got my 27w cubed. But don't I also have, 12wb squared. And don't I also have 18w squared b? Do I want these? This obviously can't be the answer because it doesn't multiply out to be this. So what do I need? I need to call up the cleaner dude. I need somebody to come clean this shit up. I don't want this blood brains on my car seat. Right? Blood brains. So right here is going to go, the guy's going to clean it up. Obviously, what sign is this going to have so it can kill these pieces? Negative. Opposite sign of what this is. And then what always works is this times this. 6bw. Do you see that? 2b times 3w is 6bw. So here it is in action. What's 3w times 6bw? Negative 18w squared b. Dead. And what's 2b times negative 6bw? Negative 12b squared w. Dead. Okay. So yeah, you do have to know how to factor cubes. I love it when students like, oh, you gave us a cube. You said, well, whatever. You're supposed to know how to factor. There you go. That's how you do it. All right. Now, everybody's favorite part. Real quick, I don't know how you were taught trig or any of that kind of shit, but I really, for example, some of you guys are going to hate me if you don't already about this, but SOHCAHTOA sucks. It needs to stop. If you were taught correctly from the beginning that cosine likes x, like I heard over here some people talking about, sine likes y. That's all you got to frickin' know. So, for example, for this kind of problem, sine likes y, so it's 3/5, right? You can kind of remember. All right, so that's easy enough, right? The angle's got to be in the base. That's the one thing that SOHCAHTOA is better at, is it doesn't matter how the triangle's oriented. But if I wanted this angle instead, I would just freaking do this, and then I don't need SOHCAHTOA, right? You guys understand? Everybody ever heard of SOHCAHTOA? Anybody ever heard of it? You got the little shirt, Camp SOHCAHTOA, and it's all fun and shit. It's shit. It takes you away from the idea. It makes you feel like, oh, if I didn't have that, I wouldn't know what to do. Do you start to understand my weird way of thinking? I don't like doing that too much. I don't need that shit. So, when I have a problem like this, here's something kind of interesting. Let's talk about sine. Sure, let's talk about sine. Sine likes y. So at 0 degrees, what part of that is in the y direction? None of it. So of course sine of 0 is 0. Because sine likes y. So when it's in a place where there is no y piece, it's going to hate it. It's going to be 0. Doesn't like it there. So of course it's going to steadily increase as you introduce more and more. So if I go to pi over, what's this going to be? 6, good. Because that's a smaller number than pi over 3, so it should be smaller, right? Now I should have a little bit of y piece. I have a little bit of y piece here. Yeah, it's too long, but don't worry. So watch this. This is kind of cool. Sine of pi over 6 is going to be what? Oh, should be the smaller option because it's only a little tiny y piece, right? So it's going to be 1/2, not the bigger option, root 3 over 2. Let me write this kind of weird for right now. You'll see why in a minute. Right? Isn't root 1 over 2 still 1/2? All right. What about pi over 4? Now it's going to grow a little bit more. Anybody know what that is? Yeah, root 2 over 2. Root 2 over 2. Do you see the pattern? Can I write 0 as root 0 over 2? Isn't that a funky-ass way to write it? But do you see the pattern? Root 0 over 2, root 1 over 2, root 2 over 2. I'll bet you the next one is freaking Root 3 over 2. Holy shit. And why does it make sense for sine to do this? Because sine starts off with no y, a little more y, a little bigger, a little more y, a little bigger, a little more y, a little bigger. And so you get, so this will be pi over 3, sine of pi over 3 is rad 3 over 2. And what's sine of pi over 2? If I follow the pattern, it should be rad 4 over 2. What's rad 4? 2 divided by 2 is 1. There you go. And what does cosine do? The opposite, because cosine likes x. It's going to start big and shrink, 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 shrink. Has anybody ever seen this? You've all seen this, the numbers, but have you seen it explained like that before? I mean, yes, you have? Kick ass. All right. Now, there's all these other, there's actually something that involves knuckles, there's all this kind of weird shit you can do. To me, this just makes the most sense about how to remember what's going on. And just remember, that number really is the length of this y piece. So that's why it makes sense that it gets the biggest, up there, and it's the smallest at 0. That's it. When I take physics, there's a lot of vector stuff. And I like to think this isn't really true, but sine is sort of like the percentage that's in the up and down direction, and cosine is kind of like the percentage in the x direction. Not really, but still, it gets you through understanding what vector is all about. Okay, I like it. So, you have to know how to do reference angles now. 2 pi over 3. It's going to be back here. How far away is that from the x-axis? Because everything's in relation to the x-axis. What's your reference angle? If you're at 2 pi over 3, how far away from the x-axis are you? What's the x-axis? How many radians? Pi. So how far away are you? I got 2/3 of a pi. How far away from a full pi am I? A third pi, right? So pi over 3, that's my reference angle. So what's sine of pi over 3? That's closer to y, so it's going to be the bigger one. And it's still positive, of course. Sine likes y, so sine is positive where y is positive. Cosine x, so cosine is positive where x is positive. SOHCAHTOA just gets muddied in there. It's unnecessary. And again, if you love SOHCAHTOA, I feel really bad for you. Let it go. Trust me. You got to trust me. Like I just mentioned you. I don't know if I trust you. All right. So this will be. There's a reference angle work, pi over 3. So this will be root 3 over 2. Now, what is it about tangent? Tangent is y over x, or more specifically, sine over cosine. I like it. Which makes sense, because sine likes y, cosine likes x. All goes together. Where am I at for negative 225? How far have I gone so far? How far have I gone so far?
180.
180. So I got to, how much more? How much more? And it's negative, that's why I'm going backwards, right? So I'm at a 45-degree reference angle. That's what matters. Now, at 45 degrees, sine and cosine are... At 45 degrees, sine and cosine are equal. Tangent is the ratio of sine and cosine. So the answer to a tangent at 45 is going to be 1 or negative 1, depending on if sine and cosine are the same or not. I am in the second quadrant, so sine is positive, cosine is negative. So the answer to this is negative 1. Because the sine piece is positive rad 2 over 2, then cosine piece is negative rad 2 over 2, the ratio is going to be negative 1. You guys semi with me a little bit? I always love it when somebody gets into calculus and they never took trig. I don't know if any of you are like that. If you are, the system has failed you. I'm sorry, you should not be here. But good luck learning trig as you've learned calculus. Hopefully that's not true of anybody. If it is, you might want to come see me. So this is negative 1. Now this one, that's got an evil in it. Because you don't know freaking over 12 shit, do you? If you do, whoa, you memorize way too much. Somebody help me out. What is oh shit. I got you pointing on it. That's the problem we're going to do. Okay. Here's one of my favorite things about trigonometry that you'll learn quickly if you look at the identities in this way. Cosine is an asshole. Cosine is an asshole. So for example, the very first place I realized this a long time ago was this guy. This is something you have to know. If you don't know it yet, you have to memorize it. If your trick teacher didn't make you memorize it, go back and slap them in the face and say, this shit's wrong with you. Or don't, it depends on what you want to do. You can imagine slapping me in the face. But I don't know if anybody remembers this or if you, some of you guys are looking at your trick sheet, but what is it? Now look, sine is sine. This is my fifth puberty. Sine is a nice guy. He's like, oh, there's a plus. I'll leave it as a plus. Why don't we take turns? Well, you know, sine and cosine will go together, and then we'll switch. Look what cosine does. Cosine says, all right, I'm going first. Screw you. That's a plus, I'm going to make it a minus. And now you can go sine. Right? Now that has nothing to do with why the formula is that way, obviously. Hopefully you've seen the derivation of these formulas. But what's important now, you've seen the derivation, they don't really help you memorize shit because they are kind of involved, but this is just a way to kind of help you remember this. And there's a lot of other places where cosine's an asshole. We'll see even more of those in calculus. So how does this relate to that problem? Well, what would cosine of 2a be? What is 2a? A plus a. So wouldn't that be cosine a minus sine a sine a? You guys with me? If it's a plus a, so isn't that cosine squared minus sine squared? Why did I put, oh wait, that's right. So if I have cosine squared, let me come back to that now. Cosine squared minus sine squared of the same angle, 5 pi over 12 in this case, I can kind of consolidate them. How can I rewrite this going backwards? This is cosine of, to do it, I got cosine squared 5 pi over 12 minus sine squared 5 pi over 12. So it's equal to cosine of twice 5 pi over 12. What's a in this case? 5 pi over 12. And what's twice 5 pi over 12? 5 pi over 6. And that's an angle we know. And now you can focus on that. Where's 5 pi over 6? It seems to be in my favorite quadrant for this whole thing. Right? 5 pi over 6 is pi over 6 away. Very close to the x-axis. Cosine likes that. It's going to be bigger. So it's going to be a root 3 over 2. What sign is it going to be? Negative, because x is negative back there. Yes, ma'am?
So you mean in that example, the 2a is equal to 5 pi over
No. What's the problem? Cosine squared of 5 pi over 12 minus sine squared of 5 pi over 12. That's the problem, right? So how can we rewrite that? What's a going to be then? 5 pi over 12.
Yeah.
So then I can rewrite that as cosine of twice a, which is bam bam 5 pi over 6,
Oh.
which is an angle I know. Okay, I like it. This is what, this is what everything before this is supposed to get you ready for, is how do I use the form of an identity in a specific problem? Identify what the parts of the identity are so you can use it correctly. So then what about this guy? What do you think this is related to? Oh, how did I freeze? Oh, there it is. I'm on the wrong sheet. I like that. This guy here. He's probably going to be related to, what do you get when you do sine of 2a? Sine a cosine a plus sine a cosine a. You get 2 sine a cosine a. Isn't that 2 sine something cosine, same thing? So a is 7 pi over 6. That becomes then sine of 7 pi over 6 plus 7 pi over 6. Now, of course, you could also just, you know 7 pi over 6, don't you? You could just attack this directly, or you could rewrite it, and both ways should come out to be the same answer. So how do I do 7 pi over 6? Where's that going to be? how much past the whole pi is it going to be? 5 or 6. So I'm close to the x-axis. So does sine like it there? Nope, sine didn't like it there. So it's going to be the tinier option. So sine is going to be it's going to be 1/2. It's going to be negative because it's down here. Cosine is going to be the larger option, and it's also going to be negative. And then you just do that. The negatives cancel. You get √3/2. Now, even if you don't want to, let me show you what this looks like. If I use the identity, a is 7 pi over 6, so I can write this as sine of 2 times 7 pi over 6, which is sine of 7 pi over 3. If I use the identity, and where's 7 pi over 3? Well, it's a full 2 pi and then a third more. Sine likes it there. It's close to the y-axis, and it's positive, so it'd be rad3/2. The same damn answer we got, of course. Of course. Any way you look at it, it's going to come out the same answer. Okay. Yes?
Why are they positive in their parentheses if they're both in the third quadrant?
Oh, they were negative, and then I canceled the negatives. Yeah, sorry. So you see that? That's why the pluses are. They're both negative, so of course they cancel each other. Cool. All right. Did anybody try the bonus one out? What does this represent? So let's do this. Do we know what this is? No. So let me call it y, just to call it something. Right? This is what algebra did for me. If I don't know what something is, I can give it an easier name so I can work with it. That's basically what algebra does. You probably want to see that. How do I kill inverse cosine? What do I do to both sides to kill it? If somebody says divide by it, I'm going to have to stand here and cry for like 5 minutes. What's the opposite of inverse cosine? Cosine. It's crazy. So I take the cosine of both sides. I get 2 over x equals cosine y. Doesn't this defines, hopefully you guys have heard this kind of thing before, this defines a triangle with an angle of y. I could draw a triangle that represents this, because what is cosine fundamentally? Isn't it a ratio of sides of a triangle? Can't I draw a triangle with an angle y and then write these in the right places? And then I can answer any stupid question they ask me about that. For example, if they want the, I always go wrong, cosecant of it, I can answer that. It's easy. So what would this triangle look like? If I put y here, there's the angle y. Where's 2 go? It's cosine. So what's cosine? What over what? Cosine is x over hypotenuse. So where's the 2 go? I know it's a little freaky with an x here, but where's the 2 go on the what side? You can do it. The x side, right? Because what's cosine? X side over hypotenuse, right? So the 2 goes here. Where's the x go? Hypotenuse, I love it. And then what's this side? It's y, by the way. What's this side? Old Greek dude will help you here. You're like, Socrates? No. Pythagorean, yeah. All right. Of course, he didn't do any work. He took all his followers' work and said it was his. But we'll look past it. We'll give the name to him. So this would be the square root of what's this? What's this sign? A squared plus b squared equals c squared. So c squared minus b squared equals a squared. X squared minus 4 square root. I love you guys. So obviously, if it's the hypotenuse you know, and another side, there's going to be a minus to get the last side, because these sides add to be the bigger side. I know the bigger side, so I got to subtract the square of this from him to get this side.
So there's going to be a minus in there. So now can you answer the question?
Now it's an easy question. Give me SOHCAHTOA if you want, I don't care. Cosecant of that angle. What would the cosecant of that angle be? What's the cosecant? What over what? It's related to what? Cosecant.
Hypotenuse over sine.
Hypotenuse over
Sine.
y.
It's the
No. Over y. Sorry.
Oh, y.
Yeah.
Y, yeah.
Because it's 1 over sine. Yeah. So it'd be hypotenuse over y. So the hypotenuse over y, there it is. X over square root of x squared minus 4. That's what it is. Minus, get in there. Once you set up the triangle that the inverse trig function describes, every inverse trig function describes a triangle with sides denoted by that ratio. Then you can answer any question that's out here just by picking the right sides. Hopefully you've done that before. Maybe it's just been a while. There's a bonus too for right now, so it's not a big deal. Okay. Any lingering questions over any piece of this thing? Any lingering questions? No. Okay. All right. So we're going to get a little bit into chapter 2, and then we're going to call it a day. Maybe a little bit early. We'll see. How you doing there? Let me stop you.